Welcome to Astrum Discovery Network. Today, we embark on a journey to find the ultimate holy grail of modern physics. Deep within the complex machinery of Fermilab, a tiny subatomic particle is shaking the foundations of our physical reality. For decades, scientists have built a house of cards, a delicate structure known to us as the Standard Model. This model explains how the universe works, describing the fundamental blocks of matter and the forces that bind them. But in 2021, the Muon G2 experiment revealed that this house of cards might be collapsing. The results showed that muons were wobbling significantly more than the predictions of our most trusted theories allowed. This unexpected wobble suggests the existence of something invisible, perhaps a mysterious fifth force of nature acting upon them. If this force is confirmed, it means we must rewrite our entire understanding of the universe from the ground up. To understand the gravity of this discovery, we must first look at the four fundamental forces we currently know: gravity, electromagnetism, the strong nuclear force, and the weak nuclear force govern every interaction in the known cosmos. Gravity keeps our feet on the ground and guides the celestial dance of planets, stars, and galaxies through space. Electromagnetism lights up our cities, powers our technology, and is responsible for the chemistry of life itself. The strong nuclear force is the titan that binds protons and neutrons together, holding the nucleus of atoms intact. The weak nuclear force is the alchemist, responsible for radioactive decay and the nuclear fusion that powers our sun. For a long time, these four forces seemed completely distinct, operating with different rules and at vastly different scales. But history shows us that nature loves unity. It began in the 19th century with the brilliant James Clerk Maxwell. Before Maxwell, electricity and magnetism were thought to be two completely separate and unrelated phenomena in the physical world. Maxwell showed, with elegant mathematics, that they are actually two sides of the same coin: the electromagnetic force. This was the first great unification. It proved that distinct forces could be merged into a single theoretical framework. Fast forward to the 20th century. Physicists began dreaming of a grand unified theory that connects everything together. The next giant leap came from Abdus Salam and his colleagues, who sought to unite electromagnetism with the weak force. They predicted that at high enough energies, these two distinct forces would merge into a single electroweak force. Experiments confirmed their prediction. The electromagnetic and weak forces are merely broken fragments of a once unified whole. This success emboldened physicists to look even further back in time, to the very first moments of creation. We are now entering the grand unification epoch, a time when the universe was incredibly hot and impossibly dense. At this specific moment, mere fractions of a second after the Big Bang, the universe was a different place. Here, the strong nuclear force joined the electroweak force to form the majestic electronuclear superforce. In this state of perfect symmetry, there was no difference between the forces. They were one and the same. But as the universe expanded and cooled, this perfect symmetry could not hold. The superforce began to break apart. The strong force was the first to separate, freezing out from the others as the temperature dropped dramatically. This separation released immense energy, triggering cosmic inflation, expanding the universe faster than light in an instant. It was this phase transition that allowed for the creation of matter, giving birth to the building blocks of reality. Matter and antimatter waged a war of annihilation, but a slight imbalance allowed matter to win and survive. Later, the electroweak force split, giving particles their mass and establishing the four forces we observe today. Understanding this history helps us see why the Muon G2 anomaly is so exciting for modern physicists. If the muon is interacting with the fifth force, it might be a remnant of that ancient unification. It could be the key to unlocking string theory or supersymmetry, leading us to the final theory of everything. We are standing on the precipice of a new era, looking into the dark to find the light of truth. The journey from the smallest subatomic wobble to the birth of the cosmos is the story of us. Physics is not just equations, it is the sheet music of the symphony that the universe plays eternally. Thank you for joining us on this incredible voyage. If you enjoyed this, please like and subscribe for more. This is Astrum Discovery Network, signing off. Keep looking up and keep wondering about the world around you. From the microscopic to the telescopic, our quest for knowledge never truly ends. It only evolves. The forces that govern the stars are the same forces that hold our biological structure together. Every sunrise reminds us of the nuclear fusion powered by the weak force that sustains all life here. Simple experiments on a table can reveal the profound invisible fields that permeate the entire universe. Nature displays its raw power in storms, a violent reminder of the electromagnetic energy surrounding us. Deep in stellar nurseries, gravity pulls dust together to ignite new stars, continuing the cycle of creation. Our technology advances as our understanding of these fundamental forces becomes more precise and refined. We stand on the shoulders of giants, reading the pages written by those who came before us. Einstein dreamed of a unified field theory, a single equation to describe the entire universe beautifully. Today, a new generation of brilliant minds continues this quest, armed with better tools and fresh perspectives. Machines like the Large Hadron Collider are the cathedrals of science, built to worship the truth of reality. We simulate extreme conditions to glimpse the physics that rule the universe at the dawn of time. The cosmos is a vast laboratory, offering us clues in the light of distant stars and galaxies. Energy is never lost, only transformed, moving from potential to kinetic, from mass to pure radiation. Like a candle in the dark, science illuminates the unknown, pushing back the boundaries of ignorance. The most complex structure in the universe, the human brain, is trying to understand the universe itself. When we look back at our home, we realize how fragile and precious our understanding truly is. Symmetry breaks to create diversity, just as white light breaks to create the colors of the rainbow. Patterns repeat across scales, hinting at a deep, underlying order that connects the small to the large. Simple equations can hold the power to destroy cities or to power them for centuries to come. We use these laws of physics to navigate the globe and to communicate instantly across vast distances. New eyes in the sky, like James Webb, appearing further back in time than ever before. Cosmic collisions provide the extreme laboratories we need to test our theories of dark matter and energy. Even the smallest disturbance can have far-reaching consequences in the interconnected web of physical reality. The aurora is a beautiful visual proof of the magnetic shield that protects us from solar winds. Ancient philosophers sought truth in geometry, and modern physicists find it in the geometry of space-time. The universe was once thought to be a clockwork mechanism, predictable and deterministic in every way. Quantum mechanics shattered that clockwork dream, introducing probability and uncertainty at the heart of nature. Relativity taught us that space and time are not rigid stages, but flexible actors in the cosmic drama. Black holes are the ultimate test, where gravity becomes so strong that light itself cannot escape. Stephen Hawking predicted that black holes are not truly black, but emit radiation due to quantum effects. The universe is a library of information, and we have only just begun to read the first page. Our galaxy is just one of billions, a tiny island in a vast, expanding ocean of darkness. At the nanoscale, the world looks alien, governed by forces that are negligible at our human scale. Fluid dynamics shows us how complex behavior can emerge from simple rules governing individual molecules. Optical phenomena, like rainbows, remind us that the world is full of hidden beauty, waiting to be revealed. We harness the photoelectric effect to capture energy from our star, a direct application of quantum theory. The screens we watch today are powered by LEDs, a technology born from our understanding of electron bands. Magnetic resonance imaging allows us to see inside the body without cutting, using strong magnetic fields. Levitating trains show how we can overcome gravity with electromagnetism to travel faster and smoother. Escaping Earth's gravity requires immense chemical energy, a testament to the strength of the gravitational bond. In orbit, we experience the freedom of weightlessness, a continuous freefall around our home planet. Robotic explorers extend our reach to other worlds, searching for signs of past water and life. The rings of Saturn are a majestic display of orbital mechanics and gravitational tidal forces in action. Giant storms on gas giants rage for centuries, powered by internal heat and rapid planetary rotation. Comets are icy messengers from the dawn of the solar system, bringing water and organics to inner planets. Impacts have shaped the history of life, driving extinctions and opening niches for new species to rise. The fossil record tells the story of life's resilience against the violent changes of a dynamic planet. Photosynthesis is a quantum process, harvesting light to build the chemical bonds that sustain the food web. Animals sense the Earth's magnetic field to navigate across continents, a biological compass evolved over eons. Sound waves travel faster in water, allowing whales to communicate across entire oceans in the deep blue. The Earth is alive geologically, its surface constantly reshaped by the heat escaping from its molten core. We are now realizing that our actions can alter the delicate balance of the planet's atmospheric chemistry. Transitioning to renewable energy is a physics problem, finding efficient ways to harvest nature's flows. Nuclear power taps into the strong force, releasing millions of times more energy than chemical burning. Fusion energy promises a clean future, mimicking the sun to create limitless power without carbon emissions. Automation and robotics rely on precise control systems and sensors to perform tasks with superhuman accuracy. The internet connects human minds, creating a global consciousness that accelerates discovery and innovation. Virtual reality allows us to simulate new worlds, testing physical laws in a safe digital sandbox. Artificial intelligence is becoming a partner in science, finding patterns in data that humans might miss. We listen to the whispers of the universe, radio waves that have traveled for billions of years. The cosmic microwave background is the baby picture of the universe, revealing its state at creation. Dark matter is the invisible scaffolding of the universe, holding galaxies together with its gravitational pull. Dark energy is the mysterious force driving the accelerated expansion of the universe, pushing everything apart. Science is a debate, a constant testing of ideas where only the theories that fit the evidence survive. Curiosity starts young, the innate human desire to understand how the world works and why. We celebrate with light and sound, ancient instincts to marvel at the spectacle of energy release. Our cities are monuments to our mastery of electricity, turning the night into day with a switch. Time is the one resource we cannot create, flowing relentlessly forward, carrying us into the future. We need a compass to guide us, both in navigation and in the moral choices of science. Knowledge is cumulative, each generation adding a new layer to the tower of human understanding. Recording our discoveries allows ideas to travel through time, speaking to people not yet born. We honor the pioneers who first dared to ask questions that challenged the dogmas of their time. Pioneers like Curie sacrificed their health to reveal the secrets of the atom and radiation. Galileo taught us that observation must always triumph over authority when seeking the truth of nature. Feynman reminded us that if you cannot explain it simply, you do not understand it well enough. Sagan showed us our place in the universe, a pale blue dot suspended in a sunbeam. Voyager carries our message to the stars, a bottle in the cosmic ocean, hoping for a reader. We broadcast our existence to the universe, hoping that we are not alone in this vastness. If life exists elsewhere, it too must obey the same laws of physics that we have discovered. The universal language is not English or math, but the physical laws that shape reality itself. Life is the universe's way of understanding itself. Matter organizing into complexity to observe the cosmos. Our eyes are sensors, evolved to detect a narrow band of electromagnetic radiation we call light. Our ears detect pressure waves in the air, interpreting vibrations as speech, music, and warning signals. Touch connects us physically to the world. Electromagnetic repulsion preventing our atoms from merging with objects. Smell is a chemical sense, detecting molecules floating in the air to identify food or danger. Taste guides us to energy-rich foods, a survival mechanism honed by millions of years of evolution. But the mind can travel where the senses cannot, exploring dimensions and scales beyond our reach. Mathematics is the sixth sense, allowing us to see the invisible structure of the physical world. We build machines to extend our senses, seeing the very small and the incredibly distant. Science transcends borders, a common language that unites humanity in a shared quest for truth. Collaboration is key. The biggest discoveries now require thousands of minds working together as one. We celebrate excellence, but the true reward is the discovery itself, the moment of understanding. We have lost knowledge in the past, a reminder that progress is not guaranteed, but must be defended. Preserving our world is a prerequisite for continuing our journey of discovery into the future. We must plant the seeds of knowledge today so that future generations can harvest the fruits. Education is the torch we pass, igniting the spark of curiosity in young minds everywhere. Amateur astronomers contribute data and passion, proving that science belongs to everyone, not just elites. The sky is a canvas, painted with the physics of light, gravity, and nuclear fusion. Eclipses were once feared as omens, but are now celebrated as predictable celestial alignments. The moon pulls the oceans, a rhythmic breathing of the planet driven by orbital mechanics. Life adapts to physics, evolving shapes and functions that exploit the laws of fluid dynamics. Even play in the animal kingdom is a lesson in physics, mastering friction and momentum. Predators are masters of physics, calculating trajectories and speeds instinctively to capture their prey. Spider silk is stronger than steel by weight, a material science marvel evolved by nature. Social insects show how simple individual rules can lead to complex emergent behavior in groups. Bees use electric fields to detect which flowers still hold nectar, a hidden sense revealed. Bats see with sound, mapping their world in total darkness using the physics of acoustics. Some animals weaponize electricity, generating high-voltage shocks to stun prey or deter predators. Chameleons manipulate light at the nanoscale, a biological mastery of optics and camouflage. Bioluminescence is nearly 100% efficient, far surpassing our best light bulbs in efficiency. Fungi recycle matter, breaking down complex molecules to return nutrients to the soil cycle. Forests regulate the global climate, massive engines of water and carbon cycling powered by the sun. Deserts show the power of wind and heat, erosion carving the face of the planet slowly. Ice is a fluid on geological timescales, flowing and reshaping entire continents over millennia. Chemistry and gravity work together in the dark, building stone cathedrals drop by drop. The treasures we value are born from extreme conditions, forged in the deep crust or colliding stars. We extract these materials to build our civilization, transforming raw earth into technology and art. Silicon, a humble element from sand, becomes the brain of our digital age through purification. Light, trapped in glass fibers, carries our voices and videos across the world instantly. Data centers consume vast energy to remember our history, our photos, and our collective knowledge. Mathematics protects our secrets, using prime numbers to lock doors in the digital realm. Value is now digital, trust established not by gold, but by distributed consensus algorithms. The digital world is a battlefield, where code is the weapon and information is the prize. Future conflicts may be fought without soldiers, disabling infrastructure with a keystroke remotely. But technology also offers the tools for peace, monitoring treaties and connecting cultures globally. We must choose how to use our power, for destruction or for the betterment of all. Empathy is the force that binds humanity, stronger than the forces that drive us apart. Our children do not see borders, only playmates, a lesson we should all relearn. Wisdom is passed down through stories, connecting the past to the future in a living chain. Art and science are twin sisters, both seeking to express the truth and beauty of reality. Music resonates with our physics, harmonies based on mathematical ratios that please the brain. Dance is the celebration of the human body in motion, a kinetic expression of joy. We design our future, envisioning cities that live in harmony with the environment. Sustainable living is the only path forward, respecting the limits of our finite planet. Waste is a design flaw. In nature, everything is food for something else. Electrification of transport reduces our reliance on ancient sunlight trapped in fossil fuels. Future transport may eliminate air resistance, traveling at jet speeds on the ground. Quiet, clean skies are possible if we innovate battery density and propulsion systems. Reusable rockets are opening the door to the cosmos, making space accessible to all. We will return to the moon, not to visit, but to stay and learn to live off-world. Asteroids hold unlimited resources, waiting for us to develop the technology to reach them. Mars challenges us to become a multi-planetary species, a backup for human civilization. Terraforming is the ultimate engineering project, breathing life into a dead world. The stars are distant, but not unreachable if we have the patience and the will. Antimatter propulsion could shorten the journey to the stars from millennia to decades. We may need to sleep through the void, waking up in a new light under a new sun. First contact would be the most significant moment in history, realizing we are family. Perhaps our universe is just one bubble in a foaming sea of a vast multiverse. String theory suggests that music is the fundamental reality, vibrating strings creating matter. Higher dimensions may be curled up tightly, hidden from our view but influencing physics. Wormholes could be shortcuts through space-time, allowing travel faster than light effectively. Time travel remains a paradox, a favorite of fiction but a headache for physicists. Changing the past might create a new timeline, avoiding the paradox of causality. Entropy increases relentlessly, leading towards the eventual heat death of the universe. Or perhaps gravity will win, pulling everything back into a big crunch and rebirth. Dark energy might tear the fabric of space itself apart in a violent big rip. Every end is a new beginning. The cycle of death and rebirth is eternal. Inner peace comes from accepting the flow of the universe, being one with the Tao. Balance is essential in physics and in life, forces opposing and neutralizing each other. We integrate ancient wisdom with modern science to heal the body and the spirit. Technology can feed the world without destroying the wild places that remain. Access to clean water and energy is a fundamental human right we must secure. Science raises the standard of living, lifting billions out of poverty and disease. Vaccines are a triumph of biology, training our bodies to fight before the battle begins. We are living longer, healthier lives, giving us more time to explore and learn. Decoding the human genome opens the door to personalized medicine and curing genetic diseases. We now have the power to edit the code of life, a responsibility that demands wisdom. Bioethics must guide our hands, ensuring we do not play God without understanding the consequences. The future is not written, it is built by the choices we make every single day. We are the universe becoming conscious of itself, a way for the cosmos to know itself. So we return to where we started, looking at a wobbling muon and seeing the universe. Everything is connected, from the smallest particle to the largest galaxy, in one grand design. Thank you for taking this journey with us through space, time, and the human mind. Don't forget to subscribe to Astrum Discovery Network and hit the bell for notifications. We will see you in the next video. Until then, stay curious and keep exploring.